example very quickly, but then I'm going to point out something that would automatically tell you that it would be no solution. So if we look here, I've got 3x minus y is greater than or equal to 2. Remember, we always have to solve these for y. So I go through, solve this for y. And by now, I think you guys have kind of got the idea of how to do this. So I'm not super concerned with taking a ton of time going through these types of problems. And I test the point 0, 0. It's false, so I shade over here. Then I'm going to do the same thing with this one. 3x minus y is less than negative 5. And again, I'm just going through and doing the exact same thing we've done before, where we solve them for y to get them in slope-intercept form, and then we graph them. And if I did this right, you should notice that these lines are parallel because they have the same slope. Oh, and actually I just noticed I made a mistake. I forgot to flip around my sign when I multiplied by a negative number. So this is actually y is greater than 3x plus 5. Which also means that this should be a dotted line. Got a little ahead of myself there. But anyways, is 0 greater than 5? No, it is not. Which means I shade on the opposite side. And here's what a no solution to a system of inequalities would look like. Notice, is anything shaded twice? Absolutely not. Okay, nothing shaded in blue is also shaded in red. But here's what you could have noticed initially. I've got 3x minus y in each case. I've got 3x minus y is greater than or equal to 2, and 3x minus y is less than negative 5. These are the exact same thing. And if you think about it, can something be bigger than 2 and less than negative 5? Well, hopefully you can tell that's not possible. And if you want to see it visually, this is why it's not possible. Because nothing that's bigger than or greater than or equal to greater than or equal to 2 is also less than negative 5. So this would just be a no solution. The reason being, there was no intersection between my graphs.